Ask a frontier AI model to write code for a user interface, and you get a clean, functional layout. But ask that same AI model to draw a pelican riding a bicycle, and things get undeniably weird. Generate an SVG of a pelican riding a bicycle. This highly specific prompt, created by developer Simon Willison, has become a widely trusted informal benchmark in the AI community. Whenever a new large language model is released, its pelican on a bicycle results immediately shoot to the top of Hacker News threads to prove or disprove the model's capabilities. With that popularity comes a persistent rumor. Developers are increasingly accusing billion-dollar AI labs of pelicanmaxxing, secretly overfitting their models to ace this exact prompt. The incentive structure makes sense. A strong result on a famous benchmark persuades users, and dominating developer mindshare translates directly to market dominance. When billions of dollars are at stake, tweaking the training data to draw a better bird is a cheap, highly effective marketing tactic. To test this rumor, researcher Castillo designed an experiment. He generated 1,008 SVGs across 7 different frontier models to extract hard data from the chaos. This investigation is a test case for a larger question. Are the metrics we use to judge AI progress being gamed at the training level? You cannot prove targeted overfitting by running the Pelican prompt in isolation. A lab might simply have a good model overall, or be trained heavily on scalable vector graphics in general. Castillo built an 8x6 matrix. The y-axis scales animals from a simple cat to a complex antelope. The x-axis scales vehicles from skateboards to airplanes. Running this through 7 frontier models yielded exactly 1,008 unique generations. The SVG code is first rendered into PNG images, which are fed to an LLM judge, GPT-5.6 Luna. Luna then outputs a 1 to 5 numerical score for each image. The judge evaluates 3 distinct criteria: visual accuracy of the animal, the vehicle, and their combined interaction. Simultaneously, the image passes to Flashlight, acting as a feature extractor to log directional metadata and specific scene elements. This precise dual pipeline architecture completely strips away human bias, forcing highly subjective, generative art into cold, objective, queryable telemetry. If frontier labs are pelicanmaxxing, the data must show the pelican and the bicycle dominating this grading rubric. This bar chart ranks the average performance across all 8 animals. The results contradict the cheating hypothesis. All 7 models draw control subjects like cats, whales, and raccoons quantifiably better than the benchmark bird. The pelican ranks 6th. Moving to the vehicle data, the target performance drops even further. The bicycle sits at 6th place, barely edging out the airplane for dead last. When you plot every specific prompt combination, the famous pelican on a bicycle ranks at number 42 out of 48. Raw scores, however, are vulnerable to inherent structural difficulty. Generating the matching wheels, frame, and pedals of a bicycle in SVG code is objectively harder than drawing a flat skateboard. To prove manipulation, we have to mathematically strip away the inherent difficulty of the drawing itself to isolate the model's actual training biases. To solve for the bicycle is hard problem, we can use a fixed effects regression model to analyze all 1,008 outputs. The regression model calculates a baseline difficulty for every combination, stripping away inherent complexity. Looking at the isolated pelican effect, every confidence interval clearly intersects the Lero baseline. The bicycle effect shows similar adherence. No lab shows a statistically significant boost. There is exactly 1 data point across these 2 variables that does not contain 0. Gemini 3.5 Flash shows a minor positive boost in the bicycle category. But with 21 tests, statistical variance predicts at least 1 false positive. Gemini's result fails the Bonferroni threshold, rendering it a mathematical illusion. Finally, isolating the exact pelican-bicycle combination, every single interval firmly crosses the 0 line, creating a visual flatline. This flatline confirms the scores for the pelican-bicycle combination are exactly what the model's general capabilities would predict. There is no evidence of targeted benchmark manipulation. Even with the regression data mapped, developers still point to visual anomalies in the outputs, arguing the compositions look like memorized training templates. The most glaring anomaly supports this accusation. Out of the 21 generated pelican on a bicycle images, 100% of them face exactly to the right. This data table shows normal directional bias. Across the entire 1008 image dataset, 60% of generations face right by default. When isolating variables, bicycles naturally face right 81% of the time, and pelicans 78% of the time. The reason is geometry. Narrow, complex 3D subjects are mathematically and practically harder to map in vector space, forcing language models to default to profile views. The data logs other recurring elements that normalize the pelican's consistency. Every single flamingo on a boat includes a sun, and otters on planes frequently wear scarves. These supposed memorization fingerprints are actually emergent properties of the model's geometric constraints and statistical biases, not a hard-coded parlor trick. General SVG optimization is a documented industry practice. Google and DeepMind have openly discussed improving vector generation capabilities as a whole, a process known as SVG maxing, which is distinct from selectively training on a single benchmark prompt. The data leaves us with a definitive conclusion. Simon Willison's famous benchmark remains honest, ungamed, and reliable. The fact that it survives scrutiny leaves us with a deeper question. Why was the entire AI development community so eager and willing to assume the frontier labs were actively lying to them? The readiness to believe the rumor points to a current crisis of trust in AI evaluation. While the specific metric is safe today, the broader threat of compromised telemetry is real. The Pelican test is clean. However, the intensity of the competition means that the pressure to produce high-performing metrics makes independent verification an increasingly necessary part of AI development. Navigating a data-dense, paranoid industry requires rigorous, independent verification. Subscribe to Syntheek Labs and let us be your filter for truth.